Okay. Now, so can you also see my screen? Okay. Great. Now, what is database? Now, the OSQL thing is actually gotten, or SQL query is gotten from the understanding of database. So without this database of the thing, nobody will be learning how to write SQL query and stuff like that. So we have to actually take it from the basic. So what is database? A database is an organized collection of data that is stored and accessed electronically. It allows you to efficiently store, retrieve, manage, and update data. Now, before this advance in technology, that's a lot of people. Okay, what version of SQL? You can download 16 or 16. Yeah, you can download 15 or 16. Express. Removed from the course. No, did I remove anyone? Uh, so okay, moving on. So database. Now let's take it back. You know, before this technology boom and everything like that, a lot of people collect data. Let's say, for example, like a supermarket now. They collect data and there's a place where they store their data. For example, I can remember back then, a lot of people use Ledger as their own source of database, and some people use Excel spreadsheet as at that time where they store their data and all. So that's the kind of like database. And but due to the advance in technology now, databases are used in wide range of applications from website, mobile apps to large enterprise systems. For example, now when you go to an when you when an application is actually created, there must be a database in that application. When the website is created, there must be a database in that website. Why is that? Because the whole process of interacting with an application or a website is like a data exchange. For example, let's say you go to like an e-commerce website now to buy something, all this e-commerce website to buy something. What you're actually doing is like you are interacting with their database in getting information. Probably you select a sneakers and you want to buy a sneakers. So what that one is doing is writing a query and sending it to database to return the data for the sneakers. That's why you're able to see the sneakers. Or let's take for example your bank application. When you go to your bank app and you're trying to make a transfer or make a withdrawal or stuff like that, what you're actually doing in the process is you are interacting with the database. And as you're actually creating or sending more money, you are sending data to the database. So what we are doing in Excel database is just the interaction with the database. So every website, every application has a database in at the back end. So you might not see it, but that is what it is. Every application they have a database. And as time goes on, as people are interacting with this database, the data that is collected from from you interacting with it is stored somewhere. So if you go there, and let's say for example now, you go to your bank app, you try to withdraw, let's say $100, for example now. You withdraw $100. Let's say you have like a $20,000 in your account or something like that. Now, when you withdraw the money, it's going to send an information to the database. Like, okay, Mr. So has withdrawn this money, update his information. So that is why when you check it, you see another. When you check your bank app data, you see that the 100 naira has been deducted from your balance. So all those processes are you interacting with the database. And when at the back end, to when the companies or the bank wanted to like, okay, let's do some analysis on people, what is the total balance or anything for people, they also interact with the database, they collect database. That shows us how important database is. And as a matter of fact, as far as data is uh, data or yeah, data is concerned, we will keep using database. Database can go out of anything because that is where we store our data. We can only just advance. For example, now before, like I said, we have Excel, whereby we store our data in an Excel sheet. Then we move from there. We move to spreadsheet. Then so from ledger, we move to spreadsheet. From spreadsheet, we move to like database. All these on-premises database that people are going to load up servers, and that is where they store their data. Now from there, we move to cloud. I don't know where we are going to next. So that is like the peak of it currently now is cloud. So we have several databases on cloud whereby people store their data. And one of the advantages of cloud is because it is scalable. It is scalable. What I mean by scalable in the sense that um, if you are storing your data, for example, now in a spreadsheet, Excel spreadsheet, there's a limit to the amount of data you can take. I think Excel has like a 1,140,000 rows or something thereabout. So when you exceed or get to that limit, there's no way you store the data again, or you can open another expression, and that's actually a very tedious process because combining everything is a lot. Now we move to all these premises. What's it called now? Database servers. Now you notice that if you, let's say you load up some rack of servers now and you store your data there, and the thing has actually get to the peak, you have to actually put some another rack of server, and doing that is a whole lot of something. It's not easy because you have to like go through some tedious process to actually install that. Now we get to cloud. One thing about cloud is this: cloud is scalable. For example, as let's say you start with a 2 million customers now, and that is the amount of database you have, like that's your size, database size. If your customer increase, like let's say 10 million, that's one thing about cloud. You can actually scale it. What you need to do is just to pay more. So they can actually give you some more space for you to actually store this. And as your customers are increasing, like that, your data is increasing, they can keep increasing your size or your database storage for you. You just keep paying and paying and paying and paying and paying like that. So those are the different things there. Now, when data is stored in the database, it can be stored in any format. So we have different formats of database. We have the structured, we have the semi-structured, we have the unstructured. So a very big, good example of a structured data is just like, let's say for example now, your Excel sheets, what's it called? Your spreadsheet format. That's a very good example of spreadsheet. Your spreadsheet. When something is arranged in rows and columns, that is an example of structure. So you have a having a column. That's a very good example of what of a structured database. And the next one is semi-structured. Semi-structured are not really in form of like a tabular. They are not in tabular form. They don't have rows and columns. They have a structure in some sense, but they are not really. They are not like that of a table. So that's semi-structured. And an example of that might be, let's say, um, like a document file. I'm still going to show you some of those things. And we have the unstructured. So the unstructured is like there's no structure. Everything is just stored somewhere. Example of unstructured data can be our audio file, can be our video file, can be our pictures. You understand now? Now, when you collect some video files, like a data or audio files, and they stored, that one is not stored in the structured format. So they just put it in a folder or something like that. So that's an example of structured format. Now, moving on. The complex combination of structured and unstructured data set is what we know as big data. These days a lot of people are saying big data, big data, big data. And what really makes this big data? These are the three main components that forms big data. The volume of the data, the amount of data that we generate these days is so much. Let's say for example now, YouTube alone, the amount of data, volume of data it generates in a day, or all these telecommunication companies, the amount of data they generate in a day. That kind of thing like that. So that is one of the things that forms big data. Velocity. Velocity is like how the data is coming in. How the data is coming in. For example, let's take for example some people that use some iOS device. Let's say these people that tap, maybe they use all this kind of like a touch and pay something. Those that use a touch and pay kind of payment system. As people are interacting with that thing, data is coming in like it's high velocity, like the amount, the rate at which data is coming in. Or let's say, for example, now, let's take, for example, YouTube or Netflix. The amount of people that are trying to interact with YouTube, they try to watch a video or try to do something, it's much. So the velocity of the data is quite much. So that's another thing that forms big data. And the variety, we have different type of data, be it structured, unstructured, semi-structured, everything combined together. So those are the things that form the big data. So traditional technology and methods are not sufficient to analyze them. Database systems have evolved to address the issue of big data as well. So that is why a lot of people are now on cloud storing their data in a very large database. We have several database management systems. We have Postgres, we have Oracle, we have SQL Server, we have MySQL and stuff like that. So these are different database management systems, but they all have something in common. Now we are going to be looking at types of database. Please, is everyone with me? If you have any question, please let me know. Are you following me? Okay, please. Yeah, go ahead. Yeah, I think I see your hand up. Please, you can go ahead. Unmute yourself. Oh, can you hear me? Can you hear me?
Okay, can you hear me now?
Yeah, can you hear you now clearly?
Okay, good afternoon. Please, I want to know what kind of software are we going to download before we start this class?
Postgres. So it's Postgres that we are using.
Okay, okay. All
Yeah,
right, thank you.
you're
All
welcome.
right.
So, it's alright. So, moving on. Okay, Deborah, go ahead.
Yes, I want to ask that can't we use other applications like MySQL?
You can actually. Can. Can.
Okay, sir.
Yeah, okay. So, moving on. Now, moving back to the database, I'm going to be the reason why I actually divide this thing into different types of database for us to understand it very, very, very well. As a data analyst, there's a lot of terms these days that they are using that probably you don't understand, and you need to understand for you to actually get the best out of all this thing. So that's why I'm going to be dividing these types of database into four major criteria for us to understand better. Now, what are the different types of database that we have? We already talk about different types of data like unstructured, semi-structured, and unstructured. Now, types of database. A lot of people will say relational database and non-relational database. They are very, very correct. So we are going to be actually dividing that in different parts. So we are going to be looking like types of database based on the data model. You understand now? Types of database based on the data model. And it is actually divided into three parts. For based on the data model, we have the what's it called? The structured, the semi-structured, and unstructured. Now, under the structured, we have the relational database. Under the structured, we have the relational database. And under the semi-structured and unstructured, we have the document-oriented database, we have the key value, we have the column, we have the graph, and we have the object-oriented database. Do you get that now? So under the structured, we have the relational database. And under the semi-structured and unstructured, we have the document, we have the key and value, we have the column, we have the graph, and we have the object database. When we talk about relational database, these are the kind of database that is actually structured in a tabular form, and they can relate in a tabular form, and the table can relate with each other. So that is relational database. Database in a tabular format that has rows and columns, and the tables can relate to each other. That's why they call it relational database. You can actually link a table together, different tables together in a relational database, and call the data from those tables that are linked. That is why we call them relational database. And a very good example of that are the common or the enterprise database that we have, the likes of MySQL, Postgres, Oracle, SQL Server, and the likes. So these are examples of what of relational database. And the another one that we have is document-oriented database, the likes of MongoDB. This one is not really common. Like a lot of people don't like a data analyst now. They don't really write query from a MongoDB like that. So we have the MongoDB, we have the CouchDB. For key and value, we have the Redis and we have the DynamoDB, whereby for the document, the database is stored in form of like a document. It just puts, I'm going to show us all these samples as we move on. It's just like a document that has a label. And key and value, I don't know whether you are familiar with JSON formats, JSON, whereby you or dictionary. For those that are doing Python, when you save your data in a dictionary format, that's an example of a key value pair store. When the data is stored in a dictionary format, for those that are familiar with Python, it has a key and it has a value. So that's that. So the column family, the data is stored in the columnar way. We are going to see that that's Cassandra and HBase. We have the graph database. Graph database are this kind of data that is using. They use this type of model in all these geographical, what's it called? All these location wise, yeah. When you, like for example, a Google Map, the kind of data model they use is like graph data model, whereby something is linking with something and linking with something. And the object-oriented database, these are the kind of database that are created on your when you are writing your what's it called, your code. Your code. When you're writing your code, this is the kind of thing that you created. You create a database. For example, you're writing a function and you try to create like a database that stores the data. So this is an example of the database. And based on the query, are you guys with me? Okay, moving on. So based on the query language, you can divide the database into based on the query language, we have the SQL and the NoSQL. SQL are structured query language. This is the kind of language that is used to actually query data or retrieve data from a relational database. That is what we call SQL, structured query language. It is used for structured data. So it is used to query or retrieve data from a relational database. That is a language that I can use to get data from a relational database. And we have the NoSQL. And the NoSQL can be different types of languages. These are used for unstructured or semi-structured database. Like I said, description, SQL is used structured query language, manage structured data stored in tables with predefined schema. So every structured or every relational database have a predefined schema. That is, there's a structure, there's a number of columns, and there's a number of rows, and everything is arranged in a tabular format. So that is that thing about SQL, and this is the language they use. What are the key characteristics of this? So they have a fixed schema. What I mean by fixed schema is they have a data stored in a tabular form, like I said, in columns and in rows, and each column have their own data type. Just like form a table in your head, or less you can use like an Excel spreadsheet thing, whereby you put your data in an Excel spreadsheet. We have different columns like A, B, C, and stuff like that. Just picture something like that. So your data is stored in that kind of format, and each column has what's it called? Each column has their data type. For example, maybe the column A is the name of participant or name of customer. It might be a text data set, a text data type, whereby the column 2 has age. Age is numeric. Column 3 has let's say amount. Amount is actually numeric also. Stuff like that. So every column is structured in that way, and they have their data type. Now, strong consistency and ACID compliance. What do you mean by ACID? ACID is actually one of the key things. It's an acronym for atomicity, consistency, isolation, and durability. Every relational database must have this kind of characteristics. There must be atomicity in the sense that when you interact with the database, it treats a single transaction like an atom. Atom is like the smallest particle of an element. So you cannot break when a transaction is seen as an atom. That is, it cannot be broken into further what's it called now? Categories. It's seen as one. That is what by mere atomicity. And let me cite an example of that. You know that when you go online and you try to withdraw money from your what's it called now? From your bank. When you are trying to withdraw money from your bank, there's two things that is actually taking place. You are taking money from your account, and they're also deducting money from your account. So you getting the money result to you them deducting money from your account. Because if you withdraw the money and they didn't deduct the money from your account, that's a loss on their hand. Do you understand that? So when that kind of thing is, the type of transaction is treated as an atom, example, that's one by atomicity. So that immediately that sometimes immediately you withdraw money from your bank, you receive a debit alert, pam, 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 pam. So that we can have a consistent data. If an organization, if the database does not treat that kind of transaction as an atom, there will be an issue. Whereby someone can withdraw $100,000 from his account and he has $200,000, and you are still telling the person that he still has $200,000 in his account. So that is one of the characteristics of the database, for the data to be consistent. Because if the data is not consistent, it's a big problem. So that is the whole point of this ACID compliance. Atomicity, it treats a transaction as an atom. There's something we call transaction. So if you did a transaction, if the transaction is successful, then the data must reflect. If at some point when you are doing the transaction, maybe you get to a point whereby you have to withdraw and transaction fail, all the things you've done they must undo themselves. Everything must fail. You understand? So if everything is success, if one of the all the transaction is successful, then everything is successful. If one of the transactions fail, then everything fails. That's what I mean by atomicity. So that we can have consistency. C is for consistency, so that you can have consistent data in your database. Isolation. So when you are doing your transaction, it isolates the hold on. Like for example, if multiple people are trying to interact with the same database, it tends to isolate individual transactions. So this one must be done before this one is done. This one must be done before this one. For example, now when you are working on a Google Sheet, let's say your data is stored in one database like that. When maybe A is working on the Google Sheet, it tends to lock the database so that you can finish your own transaction before B can do his own transaction, so that you can have consistent data. And the last one is durability, so that's the whole essence of a database. When the database is durable, That means it has a consistent what data. There's no like, okay, you did A and B is showing and stuff like that. So that's an example of relational database. Do everybody understand that? Like, do you get that part very, very well? Okay, great. So moving on. Okay, so now the third one is best for complex queries and relationship. Yeah, it is used for complex queries, and there is a lot of joins. The reason why we have a lot of joins is because we have multiple tables. We have multiple tables. Like the data is actually separated into different tables so as to avoid redundancy. Redundancy is just like you don't have data set that is actually repeated in different tables. To reduce redundancy, like that's why the database is separated into different tables. So that the data that you have this, you don't have on the other one. The data that you have on this, you don't have on the other one. So that's that. And in that kind of case, there's so many joins. So, like for example, now you need information about a customers and their maybe address and the amount of money they've spent. You have to join the address table with the customer table, with the sales table, with the amount table, stuff like that, or payment table. So it has a lot of join. Indexing and optimization. Indexing and optimization. Now, there's something about database, this relational database that actually make it very, very, very easy for us to actually query data from it. We have something we call primary key and foreign key. All this, there's a column in your database that is based on index. What does index mean? Let's say, let me explain index to you in layman terms. Let's say you have a library that you store your books. Let's say you have a very large library. Probably you are the reading type, and you store your book there. Now, let's say you want to read a book now on maybe something Mr. Love and Money, stuff like that. Maybe you want to read a book on love and money. Let me say something like that. So if you just put your book in your shelf like that, if the bookshelf is not well arranged, probably you arrange them in some other part. You have to check through all the books in the bookshelf for you to get love and money. You get what I'm saying now? You have to check through individual book on the bookshelf for you to actually pick out what's it called now? Love and money, because you don't even know the exact list that it is. But let's now take an example whereby you now structure your data. You structure your bookshelf in the sense that all the books that start with A is actually stored on shelf A. It tends to like categorize like that. For you to get love and money book will be easy because you just go to where maybe letter L is and you look for it there and you pick it up. Same thing goes with index. So indexing allows optimization of your query so that when you are trying to query your data, the database will not scan all the data that you have in the database before it can retrieve your information for you. So if a particular column is indexed and you are querying database on an index column, it won't literally go through all the information on the database. You will just go to that particular index and pick out your data from it. That is what we mean by indexing and optimization in a database. And that is one of the things we need to actually learn in this class. Indexing. So there's a column that index is added on a database, call it B3. So maybe it's on a primary key or foreign key or a particular column. Majority of time, index is always on the column that you query on the most. You understand now? We always index on the column that we write our query on the most so that it can be easy for us. Because imagine your database, you have like 12 million or let's say 30 million rows of data. And before you can retrieve your data, it's scanning all the data before you can retrieve that. That's a lot of process. You understand now? And I mean a lot of charge on the cloud. But if you are writing it based on index, you won't have to actually scan on the table. You just go straight to where the data is and pick it out for you. And that's it. For example, let's say, okay, select everything from this table where name is Emmanuel. If the index is on the name column, then it's very, very easy for it to locate the Emmanuel because it's already indexed. You just go to where the index is and pick it out for us. That is what the thing is. Please, am I making sense? I need to hear a voice. Let me know we are all following me. Okay, great. Okay, great. If you have any question, please let me know. If you have any question, please, this will be time. The understanding of this is very, very important. Very, very important. Okay, moving on. So another example of relation is relationship and inferential integrity. So one thing about all these relational database or structured database that, like I said, it's divided into different tables, and for you to actually write a query, you have to like join some multiple tables to get some query out. And another example is that when the database is updating itself in terms of when we are interacting with it and it's updating the tables, so that we can have like referential integrity in the sense that when you update a table that contains information about maybe sales, or maybe you update someone like update his address or something like that, or change his name. When that kind of changes is made, it can go ahead and make the changes in all the necessary tables that is connected to that kind of information that is made. So that when the let's say for example now I change the customer name, then I can go to probably another column that has the customer name and change it there, or I change the customer address. I can go to the individual tables that has this thing and make the change so that everything can be in a consistent form. You get what I'm saying now? So that is what the other one is saying. Yeah, someone is raising his or her hands. Go ahead, please. Okay, Deborah, go ahead.
Okay, sir. So when you were explaining this optimization, sir, I want to ask, is it just like this function in Excel that used to like sort accordingly from A to Z? Is it like similar to it?
Okay, like you mean like sorting your data A to Z? Yeah, something like that. So what it does is this: when I make index, like it tends to like give like an ID. Let's take it from that. It tends to give an ID to each rows that you have in your data based on a column, so that when you query it, it doesn't have to like notice that okay, select star from this when Emmanuel is when the name is question. If Emmanuel is on index or index maybe 209, depending on how they think you do the index or anything like that. So you won't have to now start from maybe 1 or start from 1 million to actually start looking for Emmanuel. If we just go to like probably everything is based on range, if we just go to 200 to 300, you won't be searching from 1 again. You won't be searching for 1 million. You just go to 200 and search for Emmanuel in that range of value. So yeah, it can be like something like, yes, when you sort your data based on maybe customer name, and so that you can actually get the customer that is on top or something like that. Yeah, something like that. But in a different way, but yeah, you get the idea. Do you get that, Iman, Deborah?
Yes, sir. Thank you, sir.
You're welcome. Now, moving on. Another thing is it scales vertically. Now, we have two types of scaling. We have vertical scaling. We have horizontal scaling in like database. And what by vertical scaling? For example, now there's this particular data warehouse that can do both. Snowflake is a database. Snowflake can actually scale vertically and horizontally. Let me explain this vertical and horizontal in a way that we can understand. There's something we call single system. There's something we call distributed system, whereby a single computer and multiple computer. How do I put this? Let me explain this thing the way that we can understand. For those that are just getting to know this thing. What they're trying to say is that your data or your database is stored like on a single system. Let's say like a single computer now, for example. So when it's something scaled vertically, it's scaled vertically in the sense that if the volume of the data you're actually receiving or processing has increased, that the current compute system that you have cannot take it anymore. What you can do is like to have some extra compute system in the sense like maybe you had more RAMs or you had more storage system to it. That is what we might scale vertically. And when I say scale horizontally, when you are running your data on probably on a single system and the volume of your data increases, you can add multiple computer to it. Like you can have like 3 or more computers so that all those computers can actually process the data parallelly, horizontally. I don't know whether you get what I'm saying. So vertical is the sense that your data is stored in a single computer, and when you wanted to increase the capacity of that computer, in the sense that if the volume of your data increases, you can only add more RAM and more what's it called now, storage system to it. That is what I mean by when something scales vertically. Do you get my analogy? It is very, very important for you to understand the scaling of vertical scaling, horizontal scaling. And please ask the question now, because when we get to query, all this, the understanding of this is very, very important when you get to when you start writing query, because I will just be referring to all these terms. And so if you don't understand anything at this point, please talk. Yes, it is a class. We are here to learn. Okay. Deborah does not understand. How do I put this thing? Okay. Let's see, for example, now. Who is raising up? Okay. Okay. Mr. Raymond. Ask your question. Let me take everything together. Please go ahead.
No, I just needed clarity as well. I do not understand what you were talking about.
Okay. Now, okay. When we talk about scaling vertically and scaling horizontally, due to the large amount of data that we have these days, if you go to cloud now, majority of cloud is not majority of cloud system. All the cloud system are actually it is like when you go on cloud to get a space to store your information, they have different data center in different location. That is why, for example, let's say AWS, for example, now. AWS have multiple data center. For those that actually use AWS, that's why you see maybe Asia region, South something region, South or Southwest region, something like that. They have different data center in different database, in different places. That data center is like a computer. Let's take that as a computer, whereby when they get your data can be processed on multiple computers. So if your data is processed on multiple computers because your data is large, that is an horizontal scaling, whereby your data cannot fit into a single computer. So they now divide the data into different computers so that they can process it. That's vertical scaling. Now, that's horizontal scaling when your data is processed on multiple computers. Vertical scaling is that your data is processed on a single computer. So if the volume of the data increases, what you can do is to add more RAM or add more storage system to it. And vertical scaling has a limit. If the amount of RAM or storage that you add to it, the computer can no longer take it, that is the end of it. Do you understand now? So there's a limit to the amount of volume that the data can take. Let's say, for example, you have this kind of different data is coming, large amount of data. So you can divide the data amongst the data analysts. Probably you have like 10 data analysts, and you have very large amount of data. You can say, okay, you take data from January to this, you can take January data, you take February data, you take March data, April data, and April, May, and stuff like that. You can divide the data amongst different data analysts that we have, and they can process the data on their computer. In that case, it will be very, very easy for everybody to process that kind of like data. Let's now say you are the only data analyst in that company. They now give you January to December data. Now, apart from the work will be too much on you, if your computer is not strong enough to actually handle it, you won't be able to do that work. And when it got to a point, there will be a limit to the amount of data that your computer can process, and you won't be able to do it. So that's an example of vertical scaling. So when you have volume of data, when the volume of data you are processing increases, what we do in that case, we add more RAM. That is an example of vertical scaling and horizontal scaling. Does that actually answer something also? Do you get that? Okay. Yes. So that when you get that, a lot of this is one of the big term, vertical scaling, horizontal scaling, and stuff like that. It's very, very common. Okay, moving on. Now, this is the kind of data that we use in banking and finance, inventory system, enterprise applications. So this is a kind of like database that they use, all this bank and something like that. So this kind of data that we use, because they can. One of the reasons why they use this kind of data is because of this ACID compliance. This ACID compliance is very, very important. It is very, very, very important because they want a database that has a consistent data in it. Imagine everyone goes on maybe their bank app and withdraw money, and doesn't reflect in database. The bank is in debt. Do you understand now? Is in debt, or probably you save the money, you save the money on your account, and the money does not reflect on your bank, on your balance. It's actually a big problem too. So they are very, very particular about this ACID compliance, atomicity, consistency, isolation, and durability. So that's that. An example of all these things that we have is MySQL, Postgres, Oracle, Oracle database, Microsoft SQL Server, and SQLite. So no SQL database, and these are the kind of database where we have the unstructured data and semi-structured data and stuff like that. Another name for all these things, like all these data lakes. I don't know. Maybe you guys have heard of data lakes, lake house, and stuff like that. Blah 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 blah, like that, like that. So a broad category of data do not use SQL as their primary query language and often support flexible dynamic schemas. Yes, this is an example of NoSQL database. Schemaless or flexible schema. So they don't really have a schema like that. So your data can be stored. Writing the data to a kind of to NoSQL database or semi-structured or structured database is easy, because there's no rigid structure that you have to follow before you can write your data to it. Unlike the relational database, if you're writing a data to a relational database and you don't follow the schema, there's a problem. It's going to actually throw in an error. So like this can take in the data. So data can be scaled horizontally, that you can use a distributed system. So you can process data on multiple systems like that, like that. That is why you have our cloud storage. When you store your data on your maybe S3 buckets, or what was this one, GCP storage or Azure file storage system, stuff like that. Support high speed and large volume workload. You can store as many data as you want on them. They can take it. Favors eventual consistency over strict ACID. So this one is base, it's not ACID. So base is like eventual consistency. So let's say, for example, now some transaction are processed and is not reflecting on the database yet. So this does not really bother. What this one is trying to say, like, the data will conform in the long run. The data will come in. Let's say, for example, now you did some transaction in the morning. So one thing about this data is, like, all the data before the end of today, the data will actually come in. So if it doesn't come in, it's going to come in data. That's one by eventual consistency. And so an example of this is document stores, key value, graph database, and stuff like that. So these are types of database. You can see. Do anybody have a question? Please, if you have a question, ask. Mr. Raymond, your hand is up. Do you have a question?
Oh no, I guess I've not dropped the hands the other time. Sorry.
Okay. All right. No, it's fine. It's fine. It's fine. Please, if you have a question, now would be the time. We are here to learn, and I really want us to make the best out of this, because I don't really want to like waste my time. Thank you. Thank you so much. So moving on. Um, so these are the different types of relational database. You can see MySQL, we have the time series database, we have the NoSQL. These are their different formats and everything like that. So that's just
Hello, excuse me. I'm not sure I can hear anything.
Yeah, I think he dropped out. He should be back on soon.
Oh, okay. All right, thank you.
So sorry, I didn't know I've left the call. Please, can you hear me now? Yeah, thank you so much.
Yes, I can.
Yeah, thank you so much. Um, please, where do I stop? Because I've been talking. I don't know I've left the call. Where do I stop? Please find me. Where do I stop? I think I'm explaining the OLTP and OLAP. Are we all on this same page? Hello, can you hear me? Someone has to talk. Oh. Yeah, oh yeah, please. We are okay. We are on the same. I'm on OLTP and OLAP. Okay, let me just take that again. So I'm trying to explain the difference between the OLTP and OLAP. So database is actually like categorized into two different groups based on usage and access pattern. So we have the OLTP, which is the online transaction database. This is the kind of database that our applications, websites use, and these are the database that customers interact with day in, day out when they're actually using our website or our app or to do something like that. And the OLAP is a kind of database that is actually designated for analytical purpose alone. And another name for data OLAP is the data warehouse. We call them data warehouse. And the main purpose of analytical database is for analytical queries, for you to do your analytical thing. Whether be it machine learning, be it normal, what's it called, statistical analysis, or anything like that, or data monging or something like that. So that is what this OLAP is for. The reason why a lot of people don't merge them together is that you don't even want to merge them, because if you merge the OLAP and the OLTP together, there's so much on the database, and the database can actually crash and pause all the process. Another thing is that, let's say for example now you are trying to write a query on or doing some analytical query and you mistakenly commit the changes that you made on it, then it's going to affect the whole data thing. So that is why you have to actually separate it. And one of the characteristics of all these OLTPs, because OLTP, the amount of query that or data that the OLTP process is very, very minute. The number of rows the process is not that much. You understand now? Unlike OLAP, for example, now you can run a query for like 10 million rows. Probably you wanted to analyze data from January to December, and the company works with large amounts of data. So the amount of data you might process might be like maybe 10 million or 50 million rows of data set. So that is it. So it is optimized for complex queries and analytics. So an example of that one is Snowflake, Amazon Redshift, and BigQuery. And another name for them is our normal what's it called now? Data warehouse. So that is what that one is for. Data warehouse. So another name for that is data warehouse. So any question on this part before we move on? Please, if you have question, ask now. Please, if you have any question, ask so that we can be on the same page together. Question, please ask. Okay, moving on. Now the last part, you can see this is an example of database schema. I was talking about schema the other time. This is an example of a structured schema. Yeah. So one of the characteristics of OLTP is that their database is normalized. The schema is normalized. What by normalized is that they separate their data into different tables. That is, they tend to actually reduce redundancy. What by redundancy is like they don't like duplication. They don't like where they have duplication in their data. No, they don't want that. But maybe table A has this information. Table B also has that kind of information. No, they don't want that kind of thing. That is why they actually separate their information into different tables. So in kind of database, you have like a table that has customer information, a table that has customer address, a table that has customer payment history, a table that has customer, product history, a table that has different things like that. That's why you have so many tables, and they are linked together with different keys and primary keys and foreign keys. So this is an example of a normalized table. Now, when we get to OLAP table is always denormalized. You understand now? And the reason why we have to actually follow this kind of pattern is because when we come to OLAP table, we run large amount of large amount of data. We process large amount of data. And if I'm to process large amount of data and I'm using a normalized schema, that means I have to join different tables together. Let's say I want to write a query now, and the query has to like maybe the information I'm looking for, I have it in like 6 or 5 tables. Now, writing that kind of schema whereby I'm joining like 5 or 6 tables together for me to retrieve my information is a whole lot for the compute engine. That is why when it comes to OLAP, the data schema is actually normalized. The reason why the one for OLTP is normalized because the amount of rows that is processed, that the database is processed, is very, very small. So if I'm joining 7 tables together, the amount of data I'm getting from them is like 10 rows. So it's not going to actually have much weight on the compute engine or the processor, unlike the one that I'm processing, like let's say 10 million or 20 million rows of data. So for me to do that kind of thing, then I have to change the schema. That is why we are using normalization. Do you have questions? Please, if you have a question, let me know. So yeah, so this is what we call denormalization. So the whole aim of normalization is to reduce redundancy. Join can reduce query performance. And if you are joining multiple tables together and you are running processing large amount of data, then it's going to actually reduce the performance of your query. Increase complexity, joining table A, table B, table C, table D, it's a whole lot when you're writing that kind of query. It's your query is so large that you might not even understand. And reduce redundancy, that's one of the things, keep data consistent so that you can have customer information on customer table, address on address, this on that. Every table must actually be consistent with their table. That's why that one is like that. And when I'm making some updates, when I'm doing some updates, I can actually just update the table, update the information on different tables. Understand now? Let's say I'm changing information on address, I'll change it on this, change it on that, and stuff like that. And for the normalized table, it combines the tables, the data into like fact and dimension tables, fact table and dimension table. That is an example of a schema that we have in our OLAP. Example of like data warehouse. You notice that they say star schema, snowflake schema. What's that other one say? Constellation schema. So star schema, this is an example of a star schema now. And this is kind of like a schema that we have in an OLAP database. Like your data warehouse, this kind of schema that we have in our data warehouse. And why do we have this kind of thing? So that it simplifies query by removing joins. So we don't have multiple joins like that. So if I want information on product and the fact table, I can easily join product and the fact table together. And it simplifies your query. You don't have to do multiple joins unlike the normalized table. And it improves query performance. In this kind of table like this, it won't involve when you are processing large volume of data and you are using the normalized schema, it won't have much effect on the computer engine, unlike the normalized one. So that is one of the reasons why we have to change the schema of our database when we are talking about OLTP and OLAP. Please, Any question on this? If you have question, please ask. Understanding of this thing is very, very important. Now, based on deployment and architecture, we have centralized database. This is an example when I was talking about centralized database, when I was talking about vertical scaling and horizontal scaling. Centralized database, like your database is on a single system. It's processed by a single system. That's centralized. All data is stored in a single location. And an example of this is a legacy SQL server, all these Postgres, MySQL, Oracle. That's an example of centralized database. Distributed database. Data is distributed across multiple nodes or location. This is an example of like all this cloud database. So all this cloud storage, AWS is an example of distributed database. Your data is actually distributed in different locations. Your data is processed by multiple computer, or as a multiple system. Let me put it that way. And we have the cloud base when the data is on cloud database, and we have the edge database run to data source and devices like IoT devices. So, like an example of this is SQLite. Every system have SQLite in it, and that's an example of that. And that's that. So this is an example of a cheat sheet that you can actually check for all this type of data. ACID can go through all these things. This will give you more a detailed explanation of different type of database and how you can find it. Please, are we all on the same page? Now this will be the time to ask questions. I think for the theoretical aspect, that's just a run through that I have for us. So any question will be this. It will be the best time to ask a question. Before I move to the work, rewriting the query and stuff like that, and setting up everything. Do anybody have any question?
So I have a question.
Please go ahead. Thank you so much.
Okay. So please, I want to ask this slides that you used to take us this evening. Are you going to share it with us as well?
Yeah, I can share with you. It's a large document, but I'll share with you. I can share with you.
Okay, sir. Thank you so much. That's my question.
All right. Okay. Any other question? Please, let's ask question.
Okay, I also want to ask if the recorded session will be shared at the end of the presentation.
Yes, I'm not promising at the end, like maybe like today. let me promise I'm not gonna keep. Yes, I'm gonna share it with us. It won't be today, but I should be able to share it tomorrow, before the end of tomorrow. But it won't be today.
Okay, perfect. Thank you so much. Because in my own honest opinion, I really need to take my time to now go through this whole thing again.
Yeah, please, you need to understand this thing. For those that are very, very new to it, like maybe you are just coming up with data and probably you are new to data. Yeah, you need to this might be a bit maybe much for those that are just joining in. But yeah, it's nothing is too much. It's something that you can actually read up and have a better understanding. And I will advise everybody to actually read up and have a better understanding of this. Because the knowledge of this actually helps you to know how to write a query and understand different tools better. Imagine you going for like an interview. Like, and now data analytics job or any form of data job now has gone beyond like knowing how to use Excel, which is a very, very good tool actually. Knowing how to use Excel and other stuff. That has gone beyond that. Is now they want you to know whether you have a clear understanding of a database and class storage. They just want to ask you some general question as regard this, and they will want you to actually provide answer. So the proper understanding of this is very, very important. So yeah, so that would be that. Now let's move on to our data. So I'm going to share this. Now we are moving to for the sake of this class, we are going to be looking at structured query language. We are dealing with SQL, and we are going to be looking at how we can write different SQL queries. Sorry, please don't mind my syntax. I'm just working on this. How to write different SQL queries and stuff like that. So we have the like of select from blah 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 order by types of joins, so many more like that. Now let's start with this. Now let me just bring in my SQL. Done. So for those that have PG admin, this will be the time to actually launch your database engine. So like I explained, SQL, the full meaning of SQL is a structured query language, and this is the language used to query data in a relational database. It is used to actually create query data in a relational database. When I'm by relational database, are data are actually structured in rows and columns in tabular form, and they are linked together. So that is why I'm by relational database. And the only language you can use to do that is SQL. Now, in a database, we carry out different types of activities on it, and it's actually summarized into like three or four words. I think it is called CRUD. So that one is called CRUD. Or by CRUD, that's the acronyms. So the meaning of CRUD is create, retrieve, update, and delete. That's CRUD. Yeah, create, retrieve, update, and delete. Now, as a data analyst, you might not need to create. Don't let me say that, because now a lot of people are moving on to. You might not really need. You might not actually create a database. You won't be creating database, but as you proceed, let's say for example now you move to analytical engineer now. You might be the one to design your data warehouse schema. Probably you be the one to design the schema and develop the whole star schema and stuff like that. So in that case, my rights of creates something. So, but as a data analyst, you might not really need to create a database. So what you are going to be doing majorly is to retrieve database. And that's the R part of sorry. That's the R part of the CRUD. Sorry. Excuse me, please. Just a minute. Okay, so that's the R part of this thing, like retrieve. So we have the CRUD, we have the C for creating of table, we have the R for retrieving of the information from the table. That is what we do as a data analyst. We have the U for updating the tables, and that is not really done by us. It is done by probably the system when customers are interacting with our database. So you might not really need to update the database like that. But probably you're writing a pipeline as a data engineer. So you might want to update your data warehouse and stuff like that. And we have the delete. I think this particular one is what people don't use the most. Like even by mistake, nobody wants to delete their database, because if you delete your database, that's the hold on. The person doesn't have backup. So those are the operations that is carried out in the database. But for the sake of this class, we are going to be looking at the retrieve part, which we are going to be focusing on SQL. So we are going to be looking at the select and from. Select and from are the basic syntax of every database. So you wanted to retrieve any form of information from a database, we use the select and from. So let me quickly just go through this. Hold on, please. Let me set up my database. So for us that are using the database, you can actually just launch your database. Launch your database and yeah. So for some people that just install their database, you might not really have any data here. So like we now have some data already created here. That's why you have to see a lot of things here. And when you load in your own, probably you'll be seeing only this Postgres there. You'll be seeing only this Postgres here. So that is now for the sake of this class, I'm going to be using this what's it called now? Danny's Diner dataset. So this is how we are going to get the dataset. Just follow along. For those that are just working, let me delete this. Now, for you to create a database for you to work with, just select this part, select the database. Please, if you are following me, let me know. Is everyone following me? Okay, great. Yeah. So, okay, great. Now just come to your database. Let's just create some data we can work with today. Right click on your database and click on create to create an empty database. For those that don't have anything like that, so you create a database, you can give it a name. So I'm going to be giving this one Danny's Diner. Danny's Diner, something like that. Just give it a name and click on save. So after writing the name there, just click on save. Then you have the database will be empty because if you check the schema now, this is Danny's designer. If you check the schema, if you check the tables, under the table, so you come to schema. Under the schema, you check the tables. You can see that the table is empty, so there's nothing in this database empty. So we need to populate it. Now, I'm going to take you to Danny's Diner. Although this is where you are going to be doing your assignment, but let me just quickly bring it data so that we can actually practice for today. Just go to your search engine, maybe like Google, something like that. Type Danny's Diner there. And you see case study 1. Just click on that one. Case study 1. So this is the first Danny's Diner table. So it's just like information about Danny has a diner that is sell different type of food. These are the table that the thing contains. He has the sales table, he has the menu table, and he has the members. This is an example of a relational database. The database is divided into different tables and arranged in rows and columns. This is my relational database. So you can see this is a table, this is a table, this one is a sales table. It contains information about customer ID, order date, and product. We have the menu table. The menu table contains information about different types of menu or product that is sold in that particular diner. They have the sushi, they have the curry, they have the ramen or something like that. So these are information about the product that they are selling. And the third one contains information about the members, customer ID, whether they are member or not. So this database, data we're going to be working contains 3 different tables. And for us to get the data, please follow. If I'm too fast, let me know so that I want us all to be on the same page. Please follow us as I'm doing. So to get the data, you just have to come to this part and click on edit on DB feed. So just go down to this part and click on edit on DB feed. So when you click on so can you hear me now? Okay, sorry. I lost. Like I said, click on DB feed. And this one is going to run. Let it run. Then it's going to show you the DB feed. That's where we're going to get our data. Now, so what you need to do is just come to this part and copy everything here. Just press Ctrl A. Just copy like that. Ctrl A, Ctrl C. Just copy like that. And come to Postgres or your database. You can come to your database or Postgres. Now, for you to actually now create a table in that particular database, that empty database that you just created, just select the database. Make sure the database is selected and you click on this query tool so that you can open up an interface for you to write your query. So click on that, select database, and click on query tool. So this one is going to open a blank query page for us. Now press Ctrl V, just paste everything there. And remove the first one. Don't run like that. Just remove this key schema, blah blah blah. Remove this first one. Remove this first one. Delete that one. So that we can actually just delete that first one. So after you are done with that, select everything again, press Ctrl A, select everything, and just click on this run button, execute it. This play button. And that one is going to actually run and create a table in your database automatically. So we run this, you can see very, very fast. Query returned successfully. Has been populated with the data. Because you don't have much data here. So your data is actually populated. You can actually go back to your database to check it. So come to this part, you can refresh. You can do that. Just come to your schema. After the schema, you come to your table. So I come to file and click on where's that refresh? On that object, just click on refresh. Okay. So check it again. So if you check it now, the table has been populated. And you check it, there's a column there, customer ID. If you come here again, we have the menu. So the menu has been populated too. Those are the three tables. Then we have the sales. The sales has been populated there, so you have all these things there like that. So that's that. So you can do that. Let me know when we are all on the same page. Please, has everyone done that? Okay, go ahead. Go ahead.
Hi, sorry, if you don't mind taking the pasting again. I kind of lost you. I was changing my
Okay.
screens.
All
Thank you.
right, no problem. You're welcome. So any other questions so that I can take them all together? Is everybody else on the same page? Are we on the same page? We have the data. Okay, so I'll take it that we are on the same page. So let me just do that again. So you come to select everything, press Ctrl A, like that. I believe you created your database, right? The Danny Sana database. You created that.
Yes.
Okay. So come there. So when you get there, just select that database and click on. After you select database, the one you wanted to populate with the table, click on this query tool so as to open a new query interface for you. Then after you are going to get something like this. Just paste that your query, that your schema that you copied from that DB. Paste it here. I just press it Ctrl V. So everything is going to be here. Remove this schema part. Like I don't want you to put this schema. So remove the schema part. Like just delete it. So as to have like I'm going to explain why you have to keep that schema later on. So when you are done with that, select everything. Just press Ctrl A to select everything that you have here, and you run it. Just click on this execute button, execute script, display button. When you run it, then you are going to have your database populated with the table. So that's just the whole process. Someone else.
Okay, thank
waiting.
you.
Does it? You have a table populated like that? So if you don't have populate, just click on refresh. So as to when you click on refresh, go and check your table. Under the tables, under your database, under the database, check the schema. Under the schema, check the table. You have the tables under that particular schema. Any other question? We are now starting the whole writing of query from the beginning. Please, I'm only going to be attending to people that are in this class for today. So if anybody comes next week, probably doesn't join the first class, yeah, they can follow the video. Because I don't want to see a situation whereby everyone is going to take us back. So if you are doing anything here and you don't understand, that is why it's a workshop. Please call my attention to it. Let's tackle it together. Because I'll be giving assignments, I'll give you an exercise, and I want everybody to actually do that and submit the assignment so that I can know that everyone is following and they are getting it. So if there's any part in this writing of query that you don't understand or you don't get, please call my attention to it. Please. Thank you. Moving on. So we have our table now, and yeah, we are good to go. We have our table. Let me just delete this one because I don't really. Oh Jesus. Okay. Let me delete this one. I don't really need it. Don't save. What did I just do? Oh my God. So let me click on my DVD. That is an again. So if you've populated your table, if your table has been populated, so what you can do is just click on that Danny's and create another query tool for you to write your query. Don't use the one that you use to create the table. You can create a new query tool or query interface. Just click on that Danny's that contains the table you want to write. You want to actually write your query on, and click on query tool. So now this is it. Now we are good to go. Now the first query that anyone needs to know about SQL is the select from. So the select from is one of the basic or simple syntax of every query. And I feel like there's no way you are going to be writing an SQL query that you are not going to write this two thing. So select indicates the columns you are getting the column you are trying to get from a table. Can you select indicate which column you would like to view, while from identifies the table that they live in. Select is the columns you are trying to like view, while the from identify the table, the what's it called now? The columns living. A very good example is this. If I come here and I say, just don't mind this one, select, let me just quickly write select star. From, we have 3 tables. Before we go into this, let's quickly read up on the database that we are using. Let's quickly read on it so that we can have a better understanding of what we are working with. Now, let me just do a brief. If you can read from your own end there. So, Danny's diner, seriously, blah, blah, blah. Let me just go to schema. So, Danny has provided you with a sample of his overall customer data due to privacy, blah, blah, blah. So, Danny wants to use the data to answer a few questions about his customers, especially about their visiting patterns, how much money they've spent, also which menu items are their favorite. Having this deeper connection with his customer will help him deliver a better, more personalized experience for his loyal customers. Now, when we are writing a query, when we're trying to like write a query to get data from a database, or we are trying to write a query against the database, we are not only writing a query to view the database alone, we write a query to actually answer questions. So let's say, for example, now, they want to see, okay, what's the total number of the total amount paid yesterday? You have to go to your your database, transfer that, convert that question into a query that the database will understand, and you write it and you send it for it to give you a question, for it to give you an answer. So writing a query or interacting with a database is like you answering a question. So moving on, he plans on using this insight to help him decide whether he should expand the existing customer loyalty program. Additionally, he needs help to generate basic data sets so his team can easily inspect data without needing to use SQL. Danny has provided you with sample of his overall customer data due to privacy issue, but he hopes that this example is enough for you to write fully functioning, blah, blah, blah. So Danny has shared with you 3 key data sets for this case study. We have the sales table, we have the menu table, and the members table. And this is the entity relationship. Entity relationship is like the diagram that shows how the table is connected with each other. No, at the beginning of this class, I said relational database. The tables are linked together with each other. So this is like a schema. And information and data set. So the sales table captures customer ID level purchase with an corresponding sales order date and product ID. That is the customer ID when they order from their store or their diner, and the product they order is the product ID. These are the sales information. Now, when you come to menu contains the product of the product. You can see now this one is product ID, one is sushi, and the price is 10. 2 is curry, and 15, so on and so forth, like that. And the third one is the members table. It contains the customer information and the joined it the day they became a member. So there's a table for members. So it can be a customer and not a member. It can be a customer and be a member. So it's not every customer that is a member, but every member is a customer. You get that now? So customer A joined the membership, the member group on social date, and this one became a member on social date. So those are the information. These are the 3 tables we are going to be working with: the sales, the menu, and the members table. Now moving on to our listing. So let me quickly write. Let's start from let's say sales now, for example. Sales. Let me just run this quickly for us to see. Now this one returns the table for me. Now in this query now, let's not say I say something like that. Select customer ID. Whenever you are selecting, let me just leave it like this. Now, in this case, now the select is actually indicating the column that I want to view. So I have to like state the column. While the from is identifying like which table am I getting this column from. So that's the different. That's the 2 this thing of what this select and from what they do. Select identifies what column, while the from identifies the table you are getting it from. So that's it. So if I run select customer ID from table sales, and that is why we have customer ID here. I believe this part is clear. Please, like I said, if you don't follow this, let me know. If you are not like getting this will be the best time for you to actually like ask your questions and everything so that we can be on the same page. Like I was saying, select indicate which column you like to view, while from identifies the table that they live in. Now, another thing is the asterisk. A lot of people use asterisk. I will advise you not to use asterisk whenever you are actually calling a table or writing a query, writing a query to get some data from the database. Select star means to return all the column from the table that is stated. So like I did the other time, I said select star from this star means it should return all the columns from the sales table. So if you have like 100 columns from a table, it's going to return everything. So it's not really advisable when you are writing your query, especially if your database is on cloud. Your data warehouse is a cloud data warehouse, or majority of data warehouse is actually on cloud. So when you are writing your query, it is best for you to just write the column that is needed, not everything, because the amount of data that this thing return or the processing is actually money. So if probably it takes your query like 10 minutes to run, the more and the number of rows that I return is like 100 million, the higher your money. So it's better to just narrow it down to what you want. So select star is going to return all the information from the table. There's select star from the sales table. That means it should return all the information from the sales table. Now the next one is alias. Majority of time, probably we don't like the name of our column. Sometimes some column name in the database is really very, very, very terrifying. So it's not that good. So you want to actually rename the data so that you can actually give it a proper name. For example, now this one is actually well named. Like we have the customer ID or something like that. So if I wanted to rename this customer ID, that is, I don't want to show from the returning table customer ID, then I can use alias. Alias is you renaming your table. So I say as, that is, what name do I want to give to this column? As customer. That's what alias means. That is that you return. The output table should be what? You rename it as what? As customer. So if I say select customer ID as customer from, that is, rename this column to customer and select it from information. So if I run this, I'm getting this. You get that? So that's that. So another thing I want to do before I move ahead is commenting. Now it is good to comment your query. Comment is like adding like information to it or labeling it or just putting some some information, giving some information or some explanation for those that are going to be using it later on. So that's commenting. Commenting is just so for you to comment, you just have to use this dash and you start typing your comments. So let's say this is our first. This is our first comment. So what comment is that anything that is commented, be it code, is not going to run. Anything that is commented is not going to run. And please try to like put semicolon. Semicolon indicates the end of a query. That shows that this query is what has ended. That's what that semicolon is all about. What do you call it? Semicolon. So that's that. So if you run it like this, that's it. It's returning only the customer. You can see that the output name is no more customer ID. It's now what this customer, because I've changed it. I told this thing to rename it. That's what this ask is for. Another name for is alias. Any question on that part? I believe this part is it's not that what's it called, complicated. It's quite easy for everyone. So everyone that is just starting out, please let's all pay attention to this. Everyone that is starting out, please let's pay attention. Now moving on. If there's no question. Now, the next one I want to talk about is limit. Limit is used to reduce the number of results or rows returned from a query. And if you notice that for those that are using some cloud storage or cloud database, whenever you run a query, by default, if you run some query, there's a limit to your code. Automatically, you add a limit to it. Limit is just to restrict the amount of rows or results that a particular column or table returns. That is what limit is for. And if I come here now, let's say, for example, if I select star from sales, if I have like 10 million rows or 20 million rows of data sets, and I select star from, it's going to return all the columns and all the rows for me. And in that case, that is a whole lot of money just for me to view my database. I'm actually carrying a whole lot of charges on our cloud or something. So you have to be mindful of that. So I said select star. Sorry, select uh customer ID from sales limit 5. Limit 5 should say you should return what? You should return only 5 rows. That's what that one is for. And if I run this, you can see it's only returning 5 rows. So select column name from the table name and limit. So limit comes after that. So it tells you the amount of rows or result that I should return. So this is what that one is for. Are we on the same page, everyone? Now moving on, let me just say select star. So if you are selecting multiple columns, you have to separate the column by comma. For example, now select customer ID. I think I have order date here too. Customer ID, I have to put comma space order date. So SQL is not really concerned about probably you put space or anything like that. As long as there's comma there, it's going to run. But for understanding sake, for your query to be, to be readable, then you have to actually put some space into it like that. Order. The next one is order date. Order underscore date. And for this, I can just rename it as, let's say, date. Wanted to rename it, that would be the best thing to do about it. So let me just write this query in the form of like the best form. So that's, look at this now. So if I run this, sorry, if I run this, then it's going to actually give me customer ID and everything like that. So this is it. We have the customer ID, we have the customer, and we have the date. So we can just, if I now put asterisk, the last one is, I think it's product ID. So if I say, okay, third one, I call this one product ID, product underscore ID as products. That's it. So we have all these things here. So we have customer, we have date, we have rules. So that is that. Now you have to know limits actually only affects the what? The rows. It doesn't affect the columns. So you can use limit. Limit does not really reduce the number of columns. Is the columns that is stated that is going to return, but limits reduce the number of rows that will return. So I would advise you to use this whenever you are running a query. Don't just run select star from table. Put a limit to it that okay, you only want to see the first 10 rows or first 6 rows just for for you to actually view it for the first time. And you try to like inculcate the habit of stating the columns that you want. Don't just put asterisk there. Because you don't know whether the columns that you have on that table is thousands of columns. So you have to state the number of columns that you have and separate them by what? By comma. So that's that about select star from. And the next one that we have is moving on is the where clause. Now there's difference between the where clause and the limit. Limit only reduce the number of rows that you want to return, like depending on the number that you be it 15, be it 20. You only limit the number of returns the number of rows that you want to see. Now the where clause tends to actually returns the where clause is used to filter records or information in SQL query based on specific condition. Now this is where the where clause, when you wanted to filter out the rows or the information you are getting from database based on a specific condition, that is where the where clause comes in. Now select star from customer table where the location of the customer is maybe UK, or the location of the customer is Australia, or country is what is this. You understand now? So that is where the where clause is. You are trying to like tell the database the kind of column that you want to return. And you remember the other time I told you that the column that you filter on the most is where you should put your index. And I told you about indexing when we started the class, that indexing actually is for optimizing your query, so that when you are writing some query, it doesn't scan all the tables in your database. It only goes to the specific columns that you rows that you needed. So when your regular views, let's say for example, there's a column that you filter on the most, if you apply or put an index on that column, it will optimize your query so that whenever you put select star from this, where maybe let's for example now, your index on the country column, where country is Australia, you won't have to be searching all the country in your table before you pick your information for you. You only go straight to the optimization of the query comes to. We're going to talk about this later on when we get to optimization. I believe you are too. I can't hear anybody. Everybody's too. Let me hear everyone. Please. Let's talk. Let me know that I'm talking to this thing. You can hear me. Are you with me? Okay. It's a bit cold. Yeah. Thank you. All right. All right. Great. So moving on. So where clause actually just did that one. So if I come to the where clause now, moving on. So I can also use where limit with the where clause, but yeah, I can use limit with the where clause. So it doesn't really mean. So let's say for example now, I only want to see. Let me quickly run the query. Select star from sales. You can see we have customer ID, order date, product ID. So let's say for example now, I want to see only the information for products, a particular product ID. Let's say for product ID 1 now. So I cannot come here and say select everything. Let me write another query here. Select customer ID. Customer ID, order date, the third one is a product ID, from sales. Now let me put where clause. Where sorry. Where come here now? Where product ID is equals to 2. Let's just say 2 now, for example. Now look at this. Now, whenever you are writing your query, this is the order at which you write your query. Select come first, followed by from, followed by where. Do you understand? Now select from where. You want to put limit or any other thing, it comes after the where clause. So in this case, now if I say this now, select star, select customer ID, order date, product ID from sales, where product ID is equal to 2. So this one is really going to return the rows that match this particular condition, where this condition is true. That's where the where clause is useful. So you running this now, you can see it's only returning the rows that has products ID equals to 2. Then I cannot put limit. If I want to put limit, let's say 3 now. Then it's only returning 3 rows. Are you with me? Okay, so now it is this where clause that we use different condition with. So under the where clause, we have different condition that we create. We have what's it called now? We have common operators used to where clause. We have the comparative operators. We have the equals to, we have the not equals to, we have the greater than, we have the less than, we have the not equals to, we have the less than or equals to, we have the greater than or equals to. You know, these are the different types of operator that we use with where clause. Because what we put in a where clause is a condition, and a condition must actually use comparison operator or logical operators. So these are the different logical operators that we use depending on your condition. That will determine how you are going to use this where clause. So moving on. So I've already stated here that okay, select star. Yeah, like I said, okay, where product ID is greater than, if I not say where product ID is greater than 3, sorry, greater than is greater than 3. Now it's returning, it's not returning anything. Why is it not returning anything? Can someone tell us why it's not returning anything? Anyone?
ID greater than 3.
Okay. Yeah, go ahead. I can't hear you. Sorry.
I said it's because there's no product ID greater than 3.
Thank you so much. That's it. Because there's no it's still greater than 3. That is why it's returning that. So yes, thank you so much. So that's just the whole idea behind that returning everything. So if I now put greater than 2 now, then it's going to return only what? Only 3, because the only 3 that you have. So if I do something like not equals to 2, so you can write not equals to in your database in tools. Either you write this what's it called, this one and this one like this, or you write this exclamation mark and equals to. So this is not equals to. So select start from this where product ID is not equals to 2. So I run this. Let me remove the limits for now. Let me run the limits with it. So as to see what we are doing. Returning what's 1 and 3 for me, because that's the only one that doesn't that is not equal to 2. So you have to know your query, like your condition pattern. You have to actually know your condition pattern before you run this. It's very, very important. Yeah, it's very, very, very important. It's very, very important. So moving on. So the next one we want to talk about now is here under the where condition. So you can put any condition here. Now I'm only talking about numeric value. That's why I'm using equals to, not equals to. What about text data set? For example, let's use customer ID. So if I want to use customer ID, I can say greater than A or less than A, or greater than B or less than B. You can do something like that. So you can say, okay, greater equals to A. I can say equals to A. And whenever you are dealing with text data, you have to put it in quotes. You understand now? You have to be in quotes. So select customer ID, order the product ID from sales. Where product ID, not product ID this time, customer ID is equals to A. That one will return the customer that matches that particular condition. That's that. And we have this. These are only the customers that is greater than A. We now put not equals to A. I get other one. And we have the B and C. So that is that. Now, so that's the different thing that we have here on this. So we have equals to. So you can use greater than or equals to. You can use less than or equals to. And for greater than or equals to, that one is just for to include something like, for example, now, say where product ID is greater than or equals to 2. So this one is going to be like 2 or more. So that's that. So you can use less than or equals to. So you can actually put your condition there. So you have to be able to coin your condition yourself and you put it on the where clause. And one thing about the where clause is this. So we're going to talk about having, because they do the same thing but in a different way. When we get to that, we're going to talk about that one. So moving on. Now, those are the different comparison operators that we have. Now, logical operators. Logical operators, we have different logical operators. And one of them we are going to be looking at is, the first one I'm going to be looking at is and the or. The and the or. So the and is used to combine multiple conditions on the where clause. So if you wanted to use multiple conditions on the where clause, either use the and or use the or. What is the difference between the and the or? I said it allows you to actually enter multiple conditions in your where clause. That is more than one condition. So it be like 2, 3, 4, 5, 6, something like that. But there's a catch there. You have to know the difference between the and the or. When you are doing and, the two conditions must be true before your result comes out as true. when you are using or, if one of the condition is true, the result will come out as true. And a very good example is this. Let's say you have a younger brother or sister that is just in maybe in school now, and is maybe writing a course or something like that. And you told him or her that if you pass this, let's say for example that he's taking two courses, or he's in university or high school or something like that. He's taking two courses, and you told him or her that okay, if you score 80% in course A and 80% in course B, I'm going to get you PS5. Just like that. Huh? Or if you score 80% in course A and 80% in course B, I'm going to get you PS5. Now, you are joining two conditions together using what? Using the and. The two conditions must be true before you can buy that PS5. That is, you must score 80% in course 1 and 80% in course 2 before you can buy the PS5. If you only score 80% in course 1 and you score 70 on course 2, you are not like obligated to get him that PS5 because he has violated the rules. Because one of the two conditions is not true, so the whole result is not true again. That's and. Are you following me? This is very, very important. Now the or. So you now probably reach out to him or her, tell him like, okay, if you score 80% in course A or 80% in course B, I'm going to get you PS5. If you score 80% in one of the courses, then you are obligated to get him that PS5 because that is the agreement. That is one of the conditions. One is true, then the result must be true. That's the difference between the or and the and. Can you get that? Can you get that? Okay, great. Now let's go to writing of our queries. So if I wanted to like bring down, so for this query now, so random self. Let's say okay, select star where the product ID is equals to 2, and when the product ID is equal to 2, and the customer ID is equals to A. That is, these two conditions must be met before this thing is going to give me any result. If there's no condition, like no row that actually met this condition, then it's not going to return anything. So if I run this thing now, you can see now we only have two rows. I met the condition because the customer ID A that has product ID 2 and another customer ID A that has product ID 2. That is why the result it returns this table. Do you get that? So that is that on this. Now moving on. Please, if you have any question on this part, let me know so that I can go over this part again. That's for and. Now let's move on to or. Now or in this case now, let's see. You see the difference in the result. Let me get this same code now. Just run this thing again. I say, so in this case, I'm not using and, I'm using or. I change this thing to or. So and or is for chaining what? Multiple condition. If I run this, notice that I have multiple results. That is returning any rows that meet this condition. For example, this particular row one only met one of the conditions, which is A. The other one is not met. It returns the row. As long as one of the condition is met, then it's going to return the row. So one of the condition or two of the conditions are met, it's going to return the row. So that's the difference between or and the and. So when you are using it, you have to actually understand what you are trying to get from your data before you determine or use any of this and or. But in long run, it's used for changing conditions. So you can add as many conditions that you want. You can add another one here, and this and that. You can still continue adding those conditions like that. So that is for and or. Is any question on this part before I proceed? Any question? Everybody's so quiet. I believe that this part is still simple. That's why. Yeah. Okay, now the next one I want to talk about now is between. I'm going to talk about the between and the in for today. So our time, then you can actually conclude it for today. I'm going to talk about the in and the between. So it said between allows you to select only rows within a certain range. So that's between. And in allows you to specify a list of values you would like to include. Yes. About the between. Between is actually used for numeric data. Yes. Because that's range. It's the one I asked you deal with range. So I said select. Let me use the menu table now. Let me use the menu table. Let me just see what's there. Select start from menu. Around this. You can see we have the career manager. So let me just do something with it. Let's say select product name. Comma price. Select product name and price. So I run this from menu. I want to put a where clause here. Where price between let's say 5 and 5 and 5 and 10 and 5 and 13. I run this now. You can see what this one is returning. It's only returning the price that falls between this range. You say select product name price where price between 5 and 30. Like I'm stating a range here. That's what between does. You're going to state a range and it's going to actually select only rows that falls within that range. Do you understand now? It's only going to select what's the price that falls between that range. So that is how that one and this thing. And the what's it called? The two value are inclusive. Like it's going to include these two what's it called now? Range 5, start from 5 and end at 30. So that is that for between, and it's used for the numeric data set. And the next one I want to look at now is the in operator. In allows you to like state the list of values instead of like using and to chain multiple conditions. Let's say, for example, now you want to select a customer where their name starts with A and B and C and D. Instead of now using and start writing multiple conditions, you can actually put them in the in function and put everything in just like a parentheses. So example now, like I say, where customer ID or where product name. No, let me use this one. Let me use the other one that has. Let me use the other one. So for this now, let me just run this query here. Let me copy this one. Paste this here. So I can say select customer ID, customer name, customer ID, the other date, the product ID from sales, where the product name or product ID in, then I can put it in parentheses. A, let's for example, I want to select for different customer ID. Sorry, comma B. It's customer ID. I want to put here, not product ID. Where the customer ID in, so in allows you to state multiple ID and just put them in parentheses so that the database or the query can search for each value. I mean, different condition for each value. So that's what this one is all about. So if I run this now, you can see it's only returning the customer ID E and B. So that's what I stated here. So that is the in. And this is where we are going to actually end our class for today. So I will now take any question from anyone that has any questions as we what we've talked about so far in this class. Yeah, go ahead, please. Any question, you want to ask question, anything, please, or ask anything at all, just ask now. Thank you. All right, go ahead. Someone hand is up, please, you can go ahead. and speak.
Okay, sorry. I've been following, but I actually don't know how you guys they downloaded this
Data set.
software. Yes, this SQL software. Yes,
The
please.
Postgres.
Where?
You mean the Postgres, the database engine we are using, right?
Yes, yes.
Okay, it's online. You just have to click on. I can send you the link to you on. Are you on the group? I'm going to send the link to you on group page. Share with
Okay,
you on
okay.
group,
Yes, all right.
so I
Thank
can
you.
download it from there. Yeah.
All right.
Okay.
Then my second question.
Yeah, go ahead.
Yeah, my second question is how you copy. How you copy those queries and insert those tables.
Okay.
I want to know, is it that okay, you just give us this one? How about if you want to do maybe somewhere else or something else? How do we go about that?
Definitely, I'm going to be showing us how we can bring in an Excel file or CSV or a CSV file. How you can actually bring in a CSV file into this because because if you are working with this kind of database, you want to actually load in your CSV file. So I'm going to be working with CSV file. I'm going to do that maybe in the next class. I have a lot of CSV file we're going to be using for this class. So I will show you how you can load in your CSV file into this. Another thing you can do is how to actually what's it called now? Restore a database file like a DVD rental. That's another thing we can do. Yeah, if time permits us, I can show us, but that is not of we don't really need it, but we can look into it if time permits us. But I'm going to show you how you can bring it CSV file. Share database and work with it.
All right, thank you.
You're welcome. So any other question for today? All right, Janet, please go ahead.
Okay, so I noticed that the select, from, as, and the rest are all in uppercase. So I want to
Yes.
ask, do they work fine for lowercase as well?
When you share your code with other people, they can actually understand it because all those ones are actually SQL functions. So we tend to write them in uppercase, but be it in uppercase or lowercase, they will still work fine. They will still run. The code will still run. Just for readability, that's why we have to put it in uppercase like that. So yeah, they still work. All right. So any other question again? Okay. If there's no any other question, okay. Chukwuebuka, you can go ahead.
Yeah, just want to ask, right? Instead of breaking down the query to various lines, can we just write like one stretch of? Is it going to return?
It will run. It will work fine, but it will not. Yeah, it's just like for readability's sake. That is actually one of the best way to write it. You just have to break down your query so that anyone reading your query can understand what you are writing. You understand that? Now putting everything in a single line. If I'm the one like probably reading your query, I will get frustrated. So that is why we have to put it, break it into different lines just for readability.
Okay, that makes sense. Yeah.
Yeah. All right. Any other question? Any other question? Okay, if there's no question, that'll be all for today.